Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. So my name is Asyraaf bin Haja Maideen. My matrix number is 198396. So I'm going to be the leader of practical 6 Phylogenetic tree for the course of Bioinformatics code BSM4301. So the objective of this experiment is to visualize the multiple sequence alignment as phylogenetic trees and to understand the evolution and relations of 16S rRNA sequences throughout different branches of the tree of life. So in this practical 6 of phylogenetic tree, I will cover 5 subtopics from practical 6.1 until practical 6.5. So I will explain these practicals step by step and in details. So practical 6.1, how to create a full-length 16S rRNA gene sequence. So these are the nucleotide sequence of 16S rRNA using the forward primer and using the reverse primer. So the first step that I need to do is open BioEdit and click here at the new alignment and create a new alignment. After that, I go to the sequence and click to new sequences and then upload both of the sequences earlier. The format of the sequences is DNA. So this is the 16S rRNA sequence using the forward primer and the reverse primer. So after that, the sequence using the reverse primer needs to be reverse backed. So we click to the sequence and then go to nucleic acid and then click on reverse complement. So this is the 16S rRNA sequence using reverse primer after reverse complement. So after that, we need to combine both of the sequences into a full length sequence. So we go to accessory application and click to cap config assembly program, and then we run the program. So the result should only contain one config, and we did only get one config. So after that, we have to export the config in BioEdit to Words in FASTA format. So this is the config saved in Words in FASTA format. So that's all for practical 6.1. We're going to continue with practical 6.2, how to blast the 16S rRNA gene sequence. So first we go to the website to go to the blast website, and then we click on nucleotide blast. So after that we will go to the lower bottom at the bottom right picture in the standard nucleotide blast N, which is nucleotide blast. So we input the config sequence in FASTA format. And then we choose reference RNA sequences database, and then we blast. And for me, I prefer to show the results in a new window so that if any mistakes happen, I can alter the parameters back. So in this blast, I chose to show 5,000 hits, and after that, we need to download the sequences in FASTA format, minimum 10 alignments. For this practical, I choose 14 sequences, which can be seen in the results. So that's all for practical 6.2. We're going to continue in practical 6.3, phylogenetic tree construction. So first we go to the multiple sequence alignment cluster Omega website using the link that I mentioned. Next, we select the sequence type, which is DNA, and then we input the 14 sequences from the blast search and plus also our config earlier, and then we press submit. So the results of the multiple sequence alignment using cluster Omega will be shown, and then we go to the phylogenetic tree and we analyze the results. So the results will also be properly analyzed in our results. So that's all for practical 6.3. We're going to practical 6.4, an alternative phylogenetic tree construction, which is a better solution or better way actually than practical 6.3. So practical 6.4 uses Mega. So we need to install the Mega application. We can download it from www.megasoftware.net. So for me, I installed Mega X, which was compatible to my computer. So after opening Mega X, we go to the alignment and click Edit and Build Equipment. So after clicking that, we will create a new alignment and choose DNA sequence. So this is a result of choosing DNA sequence. As you can see, there's DNA sequences over there, and we can see the species and species 1, but not filled yet. So what we do is we paste all the sequences, so the 14 sequences from Blast Search and our config in the Mega. Okay, so in the fifth step, we go to alignments, and then we align by cluster W. So this is the results, the sequences after the alignment that will be properly shown in the results. So the sixth step is to export in the alignment in Mega format. So what we do is we go to the data, we go to export element, and then we go to Mega format. And for this practical, we have to name the title of the data into 16S DNA gene sequence alignment. So after saving that, we will go back to the Mega main page, and then we go to File and open a file. After that, we will choose the file that we saved earlier, the alignment earlier, which is 16S rRNA gene sequence alignment. Okay, so after that, we will go to Phylogenetic tree and try all the statistical methods, which are maximum likelihood, neighbor joining, minimum evolution method, UPGMA, maximum parsimony. So all these data will be presented in our results later. So practical 6.5, that's all for practical 6.4. So we're going to continue with practical 6.5, compute pairwise distance. So for the first step, we go to analysis, we go to the Mega main page back again, and then we go to analysis and then go to distance, which is and then go to compute pairwise distances. So and then we will ask to fill in the parameters. We need to follow the following parameters, which is variance estimation method none. The model we use Jukes-Cantor model. Rates among sites is uniform rates, and gap data treatment we do pairwise deletion. So this is a sample of the result. The full result will be also shown in the results later. So after that, this result will be analyzed. So that's all from me, and that's all from us also. So thank you.